Check.
Hello, yeah, okay, that's up.
Okay. So now we have the pleasure of Mr. Matt Ward from Jigsaw 24, and he gets the award for the most engaging title of a presentation. And I think you're speaking from experience, so I'm looking forward to hearing what you have to say. Go ahead, take it away, Matt.
Okay, thank you very much, Wes. I'm Matt Ward. I'm head of audio for Jigsaw 24. For those of you that don't know Jigsaw 24, we're a reseller. Jigsaw 24 was initially an Apple reseller, which then branched out. And now we have an entire division dedicated towards media and entertainment, which is largely integration and resales into post-production. So I'm coming very much from a post-production background, but hopefully a lot of what I'll talk about is applicable across the broadcast production chain. Apologies for the title. It is a bit clickbait, but I'm going to stretch the analogy even further in a minute, so you'll really dislike me soon. So if we look at, I presume most people in this room are familiar with the OSI layer, and I guess most people are going to be familiar with, and I won't mention the author to stay neutral from a vendor perspective, but the Inferno. And if you do a minor sort of A/B between the two, there is a slight correlation, and I like to use this drawing as an example of why when Pro Tools fails halfway through a VO, I like to throw it out the window. So that's a bit of nonsense to start with, but hopefully to explain what I'm going to be talking about, hopefully everyone in the room is more attracted towards the picture on your left than the picture on your right. I'm going to be talking at a fairly, not completely simple level, but I won't be going into vast technicalities, which is a bit different for me, but I just want to keep things, basically, you can be as clever as you want, but if you don't do the simple things right, your project's not going to be a success. It's not going to work, or you're going to have problems. So what am I talking about? Well, I'm talking about whole facility. What I mean is, multiple production rooms. Network audio, when it's a point-to-point, when you're just connecting two devices, is generally quite easy to deal with. We've all done it. It's fairly simple. Once you start a facility with multiple production rooms, but you want them to be able to share media or share audio streams, you have to pay attention to a lot more things. So we're sharing resources, we're streaming audio between them, and we might need to integrate with video devices. And network audio, I'm sure everyone in the room is familiar with. Network audio, as we talk about it, AOIP these days, it's a transport over IP, not over Ethernet. I'm talking about production capable, uncompressed, and built on the standard technologies. So, that's what we're talking about. Transport over IP, production capable, and built on the standard topologies that we're all familiar with. So one of the things before we talk about making audio over IP systems work is, why are we bothering with audio over IP systems? We occasionally have phone calls from people saying, I want to build this system, I want to build it over IP. And when we say, why? Well, because the CEO thinks it's the future. Not really a good reason to spend a lot of money and change a system that works. But on the same side, everybody in this room that has an interest in OOP, we all want to see it succeed, and there are many advantages. So the advantages, we can have bidirectional signals on a cable, many signals on a single cable. That's not completely new. We're all familiar with MADI and other transport streams, but the scale with IP is huge. We can route audio at the IP layer. We don't have to have dedicated cross points. We can use commodity IT hardware, which, it's commodity, it's easy to access, it's cheaper. We can consolidate our clocking architecture into the audio network. We can have automated device discovery. We don't have to spend hours programming out routers. But ideally, it should be cheaper, more flexible, and efficient. Now, one of the things, I don't know, I presume people in here have read The Art of Digital Audio by Wilkinson, one of the best digital audio books. And he has a great thing at the beginning. To a disinterested observer, an ideal digital audio system and an ideal analog audio system are exactly the same. And what we should remember is, to the operators, we want an ideal network audio system and an ideal conventional audio system to appear the same. They need to capture audio, they need to process it, mix it, then they need to deliver in some mechanism. Now, the disadvantages of AI IP, and this is sort of important for making systems usable. Audio engineers are not network engineers. Really, really not network engineers. Complexity of setup, there's a lot of work goes into making these things easier to set up. But for guys that are used to plugging tape machines into patch bays, it is quite daunting for them. Particularly when if it doesn't work. If I'm used to being able to go to a patch bay or a Chrome Flame, put a pair of headphones on, see what turns up, how do I do that in the IP layer? Fear of change is universal. We all come up against it every day on every level, I'm sure. We're probably frequently part of the problem. I know I am. And then timing and clocking. I know there have been lectures on PTP today. I've delivered lectures on PTP architectures and PTP and what it is to try and tame it for people that don't understand it. But it seems really intimidating when you have all of the technical information. And certainly to operational audio engineers, it's a lot to take in. You start talking about PTP, they're going to switch off. So how do we make these things work? And at a simple layer, like the elementary layer, I've broken it down in 3 things. There's the easy wins, which is the obvious stuff that I have not done repeatedly, and it's got me in a mess. Then we've got the clocking situation, which there are problems with clocking that people don't really think about. And I haven't seen anyone else talk about it in the past. And it's a simple, obvious problem, but I've seen it really hurt people. Systems clicking during voiceover records. And it's really easy to fix, but we've seen all sorts of problems. And then some network considerations at a fairly trivial level. So some of the easy wins. It sounds ridiculous. When you're building the system initially, name all your paths, name all your devices on all your control elements. Otherwise, you spend hours looking back through references. What did we do here? What's this path? What's that path? If you do it as you build the system, you're saving yourself a lot of time and a lot of confusion when, oh, we can't route this to that. I try and always, and one of the things I do, this is going to come in a minute, but try and logically group devices doing different tasks. It doesn't really matter what it is, as long as there's a logical thought process you can explain to everyone else. So that if somebody has to work out what an IP address is, that they can do it. We always used to do it with cable numbers. Cable numbers usually defined a source and a destination and a signal type, or at least, hopefully they did. And it's another way of simplifying when you look at what is difficult for a human to understand, information designed for computers to understand, when you look at it, a way of helping it make sense. With all IP systems, you find you have a large number of points at which you can start routing things. So you can probably route stuff on the input interface. You can probably route stuff within the DAW. You can probably route stuff on the output interface. You can probably route stuff in your monitor system controller, and then you can route stuff at the IP layer. So when you say, you know, traditionally, I can't hear that signal, you go to the patch bay. Where's the patch bay? Where are people going? So try and find one space where you want to be your functional routing layer and set everything up around it with static routing. And don't let people change it. And if you can do that, or at least save presets, you're going to be okay. But if people start routing in different places to achieve different things, and it becomes the general knowledge of the facility, how do I get the VO? Oh, you do that one on that way. Oh, but how do I route this? You do that one in that. And you're going to end up in a mess when somebody changes a preset and it doesn't all work. Redundancy, so this is very much from a post-production background. A lot of these topologies have redundancy built in, and it's great for live and it's great for broadcast. and it's absolutely no good in a post-production facility. When somebody unplugs a headphone amp, you don't want your entire network system to fail over to the other network. You just don't want it to happen. So it's thinking about, is that kind of redundancy always good? And actually thinking, why is this here? Is it going to make life easier, or is it going to make life harder? Now, coming back to the logical group by IP addresses, static reservation on DHCP just makes life so much easier. You just capture the MAC address of the devices you're building your network, plug it into your DHCP server, and then you can have everything come up at the same place at the same time without setting manual IPs, without individually configuring every device. It saves me hours, do it all the time with KVM networks as well, and just basically anything that comes with DHCP enabled out the box, static DHCP, I find makes my life easier. Now, the last thing, don't just think about the logical network. The great thing about networks is there's, logical topologies, physical topologies, and the two can frequently not merge, not sit together. But sometimes, now the great thing with networks is that the logical topologies doesn't have to map entirely to the physical topology, but sometimes you actually want it to. A case in point, we built a network audio facility, but also a business network for a small 2-room audio production facility. And they wanted to do all their DHCP on their firewall. Like most small enterprises, they've got a firewall appliance, it will do all their DHCP, it will handle all their network services. And that's in a comms room. But then most of their audio facility is has its own machine room, and then they have the audio rooms around it. So think about that. If I lose all of my network services in the comms room, I don't want to take my audio system offline. The fact that it's physically separate, move the network services for the audio network to where the audio is. It sounds silly, but it's a kind of mistake network engineers make because they're thinking logically and they're not thinking what is the real production requirement. And the last easy win, and it sounds ridiculous, is cable performance. It sounds stupid, but until you spend 2 days trying to fix click problems, assuming it's clocks, chasing clocks, looking at Wireshark, driving yourself mad, being sure everything is set up properly, and then you find that you swap a patch cord on an unrelated device somewhere else in the network, and suddenly everything works, and you want to smash your head against a wall. So it sounds ridiculous, but Cat6, Cat5 cables, there is a performance element to them. Are they appropriately performant? Do they measure well? So that Cat6 cable that's been sat in your comms room, it's been trod on 20 times, has the tab missing, is probably not going to perform to the Cat5, Cat6 standards. So try new patch cables, £2, €2.50 a time. Buy new Cat6 patch cables. Don't reuse broken ones. If somebody's doing structured cabling in your facility and they're testing it with a continuity tester, you don't know what that cable's performing at. Make sure you've got DTX tests. Make sure you've measured near-end, far-end crosstalk. All of these things will affect your network performance. And it's ridiculous. A number of times audio facilities, or we get a support call saying, I've got a problem, and it's a patch lead, is crazy. So those are the easy wins. That's really easy stuff that's good process and should make your life better. Now, clocking, this is ridiculous. I'm going to be, once again, very sort of BuzzFeed and tell you that the best master clock algorithm has a fatal flaw. It doesn't. It's great. It works. We all know it works. And hopefully, is anyone in the room doesn't know the best master clock? There's a million presentations. And it works. And so if you lose your clock off a network, you're going to fail over. It's going to find the next best master clock. That's brilliant. Now, the problem is that only applies if you lose your network connection, not if there's an interruption in the clock within which you've assigned your master clock. And if you have an interruption in the clock which is currently assigned to the master clock, you're going to get an interruption on your network clock. The best master clock algorithm doesn't care about that. It only cares about the network connection to that device. Now, in a large broadcast facility where you've paid attention to your clocking, you're going to have a stable grandmaster, a failover grandmaster, and you're probably not going to encounter this. In a small facility where the manual says on my DAW, I need to set my DAW to the master clock, and there are 3 DAWs, well, should people follow the manual? You can't have 3 master clocks on the same network. And secondly, if I'm making my DAW the master clock and I need to do a job at 44.1 and change the sample frequency, I'm going to get an interruption on my master clock. And if I get an interruption on my master clock in facility A, I'm going to get an interruption in master clock in facility B, where they're currently doing a voiceover or printing a master or streaming out to a destination. And it's going to ruin the take. So that's obviously unacceptable. And so you really need to think about, even in small facilities, how is this clocked? And not necessarily what the manufacturer's instructions say, because the manufacturer's instructions are generally made to make the setup as easy as possible. So what we started doing, what we started doing is supplying master clocks, even in the smallest facilities, any network audio. So we know what the master is permanently, so it sits there and runs. And so if you need to switch sample rate on DAW1, it's not going to affect anything else. And we've seen, it sounds ridiculous, but we've seen that problem in so many times when people have just bought a bunch of network audio devices, strung them together, not spoke to us about the integration, and just assume that if they set it up, it will just work. The last thing just to mention that you should always keep in the back of your mind is that PTP is a time protocol, not a timing protocol. So if you look at the open source Linux PTP stack and you lock it to a number of Dante devices, you'll find whatever VM is running on that it starts taking its actual time information from that network device. And we've seen that very rarely, but it's something to always bear in mind, that PTP is not like a word clock, it's like NTP, but more accurate. So a few networking considerations that we found relevant, and this is at a trivial level. You know, the clever network engineer, I'm sure there's lots of great network engineers in here, but these are the simple things you could communicate to less technically advanced people that will make their lives easier. So, you know, network segregation in QoS, you know, it's not required to keep, unless you have differing types of traffic on the same network segment, it's not necessarily required. We always try and do it because what you find is you're always running some kind of control on your audio network. It's really difficult. There's so many devices which have the single port for the audio and the control. So we always do, but at that point, you know, it's essential, although obviously it depends on the volume of control stuff. Spanning tree protocol, number 1, phone call. Your switch doesn't work. What's the problem? Oh, every time I plug something in, the port goes down. Have you turned spanning tree off? I haven't turned it on. Have you turned it off? Switches ship, spanning tree turned on. If you've got segregated VLANs, one for control, one for network audio, you don't want to trunk them because you don't want them to share bandwidth. Individual connections between switches, you've breached spanning tree. So unless you know what your spanning tree protocol is, you know that it's a per VLAN spanning tree protocol, and you know that you're setting it up right, turn it off. Hopefully, you've not got so many users that just go round plug in. Hopefully, your switches are locked away in a cabinet somewhere. But you know, I'm not saying that the best thing is to always turn spanning tree off. I'm trying to say, if you don't know what your implementation is, if you don't know what you're doing, turn it off. And not necessarily don't know what you're doing, but you don't know that you can cover the eventualities that might arise. Because once switches ports start turning themselves off, yeah, that's a support call. It's a broken switch, and it's a nightmare. And we've seen very educated, very competent people phone up with that exactly. You know, ports are turning off. Sorry. And then last thing, try and train your operators when multicast is appropriate. But, I mean, obviously, as we get into AS67, 2110, particularly, you know, or bridging Dante to AS67, you have to use multicast. But training your users, and it's as simple as in the bad old days. When would you use a bad old days, good old days? When would you use a distribution amp? When would you use a parallel? You might parallel two devices. So yeah, if I've got a stereo signal, it needs to go to two different destinations. I might just not use multicast because the network overhead's not going to be massive. If I've got 40 destinations for the same stereo signal, then I'm going to start thinking of it, or not start hopefully a lot earlier, but then I'm going to be thinking about using multicast. And it literally is once you get to a point where somebody wouldn't parallel an analog audio signal, that's when you should be thinking about using multicast. So thank you very much. A little earlier, I've raced through it a bit because I wasn't quite sure last time I did this it was an hour. So hopefully that's good.
Well, clearly, Matt, you've had a lot of trial by fire, listening in the lessons in the real world and things like that. So if anybody out here has any questions, this would be a great opportunity to find out from somebody who's done it for real. One question I had, you mentioned that spanning tree, turn it off, and I certainly don't disagree with that. Now, some people say that you should have on your control network, you might want to have spanning tree on and have it off on your media network. Would you comment on that? Is that a valid philosophy?
Yes, but once again, it comes down to if they're VLANs sharing same switches. So if you've got multiple switches all split into two VLANs in whatever proportion, and you're distributing it, then yes, that will maintain the spanning tree, and that will work, yes, exactly. The trouble is then you get, a lot of implementations that we're doing is actually the endpoint switches for each room are actually, they've got 4 or 5 networks on. They'll have a media network, they'll have a shared storage network, they'll have an audio network, then they'll have the local control surface network. Where at that point, if you say only one network, I wouldn't like to say just the control network. If you leave spanning tree on only one network, but that comes into having a plan. If you've already got that plan and you've got a per VLAN spanning tree protocol, then you're good. You know what you're doing. Well, it's the not thinking about what you're doing with spanning tree that's the issue. So if you haven't thought about it and got a plan, turn it off. But if you've considered it to that detail, then yeah, you're absolutely right. Leaving it on one subnet is great.
Okay. Anybody else? Any other questions? Okay, well, thank you very much. And
Thank you.
just a reminder for everybody, we will have these videos posted on the VSF website, the VSF YouTube channel. Go to vsf.tv. And also scan your badge at the entry, and you will get a link to where you can download the presentations and everything like that. So, we'd like you to use this information, and our next talk will start in 5 minutes. Okay, thanks, Matt.